Yellow's back. Hello. Good afternoon. All right, AES Day 2. We have a great panel coming up next. It is combining IT and OT, creating and deploying digital twins to solve real-world problems. I wish I had a digital twin. Moderating the panel is Dijam from GridRaster.
I'm next to you.
Are we ready to go? Okay. All right. Let's start off with the introduction. Round of introduction. Alex, why don't you start first?
Okay, sure. I'm Alex Goldberg. I'm from Blue Origin. I lead our reality capture initiative. I brought the technology to Blue. I'm incredibly passionate about building digital twins. I think that it's like I get to move through space and I'm digitizing reality. I'll stay up to ungodly hours to complete a scan because I believe in it, and I've trained lots of people at Blue in being able to do that, and it's a technology that I'm really excited about.
Awesome.
Yeah.
Carrie?
Hi, I'm Carrie Knight. I work in the Smart Manufacturing Group at Cargill. I am the product manager of Connected Worker. Terrible term, I hate that term. I started out with digital twins, so answering what is my stuff. I have other products that answer how do I do things to my stuff, what did I do to my stuff today, and how do I install, start up, and commission stuff.
Mamta, please.
Hi, my name is Mamta Abbas. I am architect and technical lead for the digital twin team in ConocoPhillips. I have been working in the oil and gas for over 14 years. And in general, I'm enthusiastic about technologies to solve real world problems.
Awesome. Michael.
Yeah, Mike Hughes, work for Cummins and lead a group called Digital Engineering. And we're focused kind of in two areas. One is around connected vehicles. Before that, I worked on a lot of service and Industry 4.0 related items in manufacturing. But the other side of my team is we've been using the AR, VR capabilities for lots of different applications over the past 12 years. And so that's kind of the other function we deal with.
My name is Jolly Ehiavi. I work for Oris Elevator. So under my belt, I have about 16 years of experience working as a smart factory manufacturing manager. So I'm in charge of applications, especially when it comes to Industry 4.0. So I pretty much kind of buy into every technology that is going to bring improvement for our factory. So I manage a lot of real-time monitoring solution, building digital twin solution for the factory. And I also oversee a CNC programming team, which I have a lot of mechatronic engineers working under me. And so training for me is a daily thing, training them and also making sure management gets a buy-in into some of this new technology.
That's awesome. We are missing one stalwart here today, like Ed. He couldn't make it, but you would have been immense to the discussion too. Just a little bit about me. I'm Dijam, one of the co-founders of GridRaster. We have been working on the digital twin and the immersive space for the last 10 years, so seen the ups and downs, everything, the roller coaster. We're still kind of hopeful things are going to pan out well. But let's start up the discussion with the very basic question. What is a digital twin? Because from my conversations with the various organizations, like the digital twin for each of them is a little different. Some they're good with the dimensional measurements of what you're looking at. Some they don't really care about the fidelity. They're looking at the functional elements of it. Why don't all of you go through and just define what digital twin means for your organization?
Yeah, sure. It's a word that is, I suppose, contested in certain circles. Some companies, they will call a digital twin data on a spreadsheet regarding activities in a certain area that is the digital twin of that area. At Blue, it is referred to, reality capture is the means of scanning a facility and then being able to disseminate that. We refer to those as digital twins. I think everybody is striving to have a higher level of fidelity in those models, whether it's IoT sensors, real-time data for all the activities that are going on, the ergonomic poses of end users at the current time in that facility would be an incredibly accurate digital twin. So I think we're inexorably racing towards having high fidelity to our models and digital twins of varying degrees. I don't know, was that too vague of an answer?
No, that's what digital twin is. Let's go ahead, yeah.
So for me, a digital twin, it's another word that I don't really like because it means something different to anybody who asks, just like my title, connected worker, could mean anything. And so for us, a digital twin, it's our digital asset twin. And I like to refer to that as the Google of our plant. So it is your one-stop shop to find anything that we know about our assets. It's the integrator of all of our disparate systems. So you have that one place that you go to, you search, and we show you everything you need to know. With it being connected to the source data, you maintain your single source of truth. And then we ground that with visualization. And our visualization isn't 3D CAD models, it is reality capture, laser scans.
Awesome.
Well, I'll echo the same sentiments. The digital twin is a very kind of an open word, depends on your use cases. So for ConocoPhillips, we have defined digital twin as a digital representation or 3D representation of a physical asset connected with relevant data to provide business insights. And also it's, of course, the counterpart of your physical asset and for the life cycle management of your asset and provide you the insight related to your spatial awareness and connected to all other system and also the real-time integration. So yeah, it's the fidelity comes through the digital twin if you integrate with your different system, right? Because it's the data, it's this integration of, system of integration essentially for me.
Your system level fidelity, okay. Michael.
Yeah, I think the area I'm in, most of my time is spent on kind of the digital twin of a product application, whether that's like a mining hauler or a semi-truck or whatever it may be. And so some attributes that we kind of think about when we use that concept. For one, it has to have some level of connectivity. Some people immediately think about telematics connectivity, but we find that there's latency. In some cases, you may only get data once a month. And some data, you might get data every day. And some data, you might get, whatever. And so I think just understanding that. And then the next piece is there needs to be some type of a model as a part of that to create like features themselves that create real value. So algorithms of some type, whether they're physics-based or if they're mathematical, statistical-based, there has to be some type of a model. And then the last part, which we think there's a lot of value creation, is how do you create proactive insights? And so you're not reacting, you're trying to work in advance. And so that's really where we're trying to move, is how do we get ahead of things? Instead of diagnosing things, we can get ahead of things. And so that's usually what we think of. Again, there's lots of puzzle pieces required to get there, but those are some of the attributes we speak.
Awesome. So for us at Oris, when we talk about digital twin, we're looking at our factory because I work in the new equipment products for Oris. So we are looking at our process. We have about 200 manufacturing cells. So for us, it's a virtual representation of those cells, where we have to connect our ERP system, connect our real-time monitoring solution. We built a 3D model by doing physical scanning of the factory, and then we use that application to run a simulation model to do like what-if scenario, because almost every year we are tasked with forecasting what each of those manufacturing cells are going to be producing. Sometimes when you ask those who work in the production environment, especially like production supervisor, and say, hey, you have 10 people call out today, what's going to be your throughput from the line? Sometimes they come with a paper and say, hey, yesterday we made 10, today because somebody's out, we're going to make 8. But with this kind of solution, we've been able to make some informed decision and say, hey, based on our model, if we do this, we'll run a what-if scenario. This is what we're going to be capable of making. So for us, it's all cut across connecting the assets in the shop floor, putting in your ERP system into it, your real-time monitoring solution into it, and also connecting every sensor that you have out there to make some informed decisions. So when we talk about digital twin, we're looking at a model that is not just a 3D model, but it's a model that is built with simulation into it, so that we can be able to make some good decision that helps and drive improvement in our processes.
No, that's awesome. I think the sense that we get everywhere is, it's basically a 3D model that integrates the operational environment with the informational environment, and then you bring it all together. That's when you make the most out of it. One of the things that often I think is driven, like the digital twin is primarily driven by the data, right? And so one question how critical is those foundational data that you have found based on like the work that you have done within your organization? Like what have you done, any ways that you're looking to kind of collect, clean, and organize? Just Carrie, can you just throw some light on that? Yeah.
Yeah, so we have 600 plants worldwide. Every plant kind of operates in their own way. So our objective was we want a single platform that everybody uses. And we had to go to each facility. We've rolled it out in some way, shape, or form at about 40 of our plants. So it's going to be a long journey. But some of our plants, all paper-based. Some of them, network drives, SharePoints, combination thereof. So our first objective was, well, what stuff do we have? And so we uncovered all these little tiny piles of information, gathered all of that up, and then said, all right, tiny piles of garbage equals garbage mountain. Now let's go through this and figure out exactly what it is that we have and what we are missing. So the foundation of everything is, what should we know? What do we actually know? What would we like to know? And so each system that we also have that we're trying to connect in might call it slightly different. So then we have to create a data map between each system so that when I say, give me information about this pump, we're all talking about the same pump in all of those systems. And without that foundational layer and understanding, like you're just throwing, your little tiny piles of garbage are never gonna get sorted out correctly. And that foundation that we're also laying with that information is feeding into the Gen AI and the AR, VR stuff. So it's very important for that foundation to be set correctly.
Awesome. Mamta, how about you?
Yeah, data is essential everything. It's a foundation, right? And for a digital twin, of course, there are three kinds of a data. which creates the digital twin, either the 3D model, the CAD model, or the reality capture, or the 3D or 360 photography, right? So the approach that we took in the beginning when we started our journey is like, let's build a digital twin for a data which is clean in this aspect, which is a 3D model, right? So we started with the business unit, which has the 3D model management process also, right? So 3D model is one data, right? We need to overlay this data with our ERP data, right? Or integrate with other data system. The good thing that happened in our organization in the last couple of years is that we went through the next gen thing where we upgraded our SAP system, where our ERP system, which has all the asset information, right? So for the structured data, and we did the data modernization, the Snowflake, we have all the data in the Snowflake, so all the structured data is in the Snowflake. So we build this data, the visualization digital twin, we overlay with our structured data and the unstructured data, which is a document, right? All the engineering document types, right? Which is, of course, all the BU have a different flavors. We are trying to have us come to the single platform. But we build a kind of a process so that we can feed to our digital twin application the same way all the documents. So we build the process with each EDMS system and bring those data. So this is how. So we scaled our 3D model-based digital twin across 4 BUs running in the enterprise architecture. Our next phase is, of course, the reality capture data, and that's where the real challenge is, because the reality capture depends on which vendor we are using to capture the data and how the process is, whether the output from that process is compatible or interoperable to other application or not. So that's the challenge we still have to kind of solve, but yeah. Yeah, it's still open for us.
But it's good to see that like few views you're already kind of putting into production, right? Jolly, how about you?
So for us, we have a 500,000 square foot facility in South Carolina. When we started building a digital twin solution for that facility, the first thing that came to mind is we have a lot of machineries that are worth millions of dollars. Now, they are legacy system. So for those of you who have dealt with legacy system, you know it's very hard to connect to those systems, to get information from those systems. So, but what we did is we were able to kind of go around it, working with a third party to collect those data and then clean them up and get them ready for what we need to use them for. And also, we also build a process where we build playbook for every single product line that will run in this in our manufacturing cell. So we kind of go back to our Excel document, get those information, clean them, and put them in the format that is acceptable, that is capable of using it for our solution. So basically for us, we believe that your solution is as good as the data or the information you pass into it for us. So we dealt with a lot of legacy system. We have a lot of PLCs across our factory. And so for us to be able to get those information, the first thing for us, being in charge of those projects, I got a company that can help us really clean those data, clean those information, and then pass it into our digital twin solution. So it comes down to scanning the whole facility. And sometimes if you work in a production environment, you know the production line wants to run every single day of the week. So you have to find a way to schedule those scanning, right? Because for those who do 3D scanning, you know, you might not want to have people walking around when you do the scanning. Sometimes it all depends on what company you're working with. So for us, we went through that challenge, but we were able to get the information we needed. And then it took us almost like 6 months to start cleaning those information, because it's not just to have a solution and it might look good on the application, but you want to be able to have something that's a real representation of your real asset in the shop floor. So for us, we take that very serious because I don't just want to implement something that looks good just to myself, because we have 17 factories across the globe, and we're going to be building best practice. So for you to be able to do that, your solution has to give the right information. So data for us is important, and we went through the stress and the pain to clean up those information. And also, we also use an ERP system that is almost like maybe a little bit behind when it comes to technology. So we were also able to look at that system and be able to clean up the information coming from that system so that we can have a real informed decision when we start using those data to run our digital twin solution.
Awesome. They say data is like the eggs, so the omelet is as good as the eggs, right? So yeah. All right. So yeah, with the rise of all the generative AI, advanced analytics, so how are you all preparing for this? Is there any particular wins or experiments that you have from that? Alex, let's start with you.
Well, first of all, with our current technology, with our current set of digital twins, I'm excited about the prospect of using AI to correlate model IDs from our CAD PLM with their real-world counterparts and then making them searchable. So having that wired up would be very helpful. We haven't achieved that yet, but I think that's an obvious direction to go. I'm about to kick off a POC this fall where we'll be using AI to attempt to execute root cause analysis against volumetric captures of our facilities of a specific workstation. We'll be able to track all the parts moving in and out of that area, as well as all the personnel and their activities, how much walking is in between, and we'll be able to determine a lot of juicy analytics from that. I think AI for root cause analysis can be a big win, as well as leveraging existing data to, again, correlate that with model IDs in your CAD PLM.
That's awesome. Michael?
Yeah, we started this journey around, I'll just speak to the connected vehicle space, in the 2019 timeframe, and different, some of our different business units executed at different times based on what electronics hardware architectures they had in place that could enable and facilitate connectivity, and then kind of where there were ripe opportunities to create new algorithms that could create value. And so, yeah, we've got multiple different kind of scenarios. So if you want to look at like the mining business, for example, those vehicles can be connected and transmit lots of data all the time because of the opportunity and the downtime. Costs are so high. If they're hauling copper in a copper mine, for example, 1 hour of downtime could be tens of thousands of dollars. And so there was a lot of development that happened there, just super fast. But then when you go into like markets where we have a lot higher volumes of product, it's you have to think a lot differently, because telematics costs become very expensive very fast. Where you run your computing, whether it's on the edge on the vehicle side or in the cloud, becomes a very costly factor. If you're running an algorithm against 1 million vehicles, you've got to really think about that, because it's just a compounding effect as you add more algorithms. And so, yeah, I would say in both scenarios, yes, we definitely have examples of where these twins are being used. One that I was a part of in the early days that was a fun project was around oil health monitoring. And so we, long story kind of made short, a lot of these, if you just want to think of a semi-truck, for example, if it's going down the highway and you're running it in the mountains carrying steel, or if you're running through the Midwest and you're carrying some lightweight load, traditionally your service manuals and things like that give you a very conservative estimate on when to change your oil. And so when you have the data and the validation mechanisms with your oil samples and everything, you're able to quickly see that in some cases you can extend your oil life out significantly, or you actually in some cases potentially need to go the other way to protect your product. And so that's just kind of a simple scenario of that created a lot of value and didn't require a lot of telematics data, I guess you could say. And so, yeah.
Mamta?
I would say the AI space first rather than saying the Gen AI thing. So as I said, 3D CAD model is easy to build a digital twin, right? But challenge comes in the reality capture data, and especially in our company, our unconventional asset is mostly through acquisition, which of course they do not have the 3D model, neither their P&ID documents are not that great. And so we have a challenges in that space. And I think we are also starting doing a POC to use the AI to identify in an asset the equipments and all, and connect it with the P&ID, so that once that data is connected, we can connect with all others ERP and non-ERP data and bring some fidelity to the digital twin to do operational workflow. So that's the AI part. We do have a challenges in the XR space also, because this technology has also evolved in last few years. So when we started looking into this, so we had challenges with the hardware. Our company has its own security, IT, OT security guidelines, which is little difficult to cross, and we can't bypass it. So like adopting in and scaling is another challenge, and also training the user using these technologies has also not been very successful. So adoption. So in both the spaces, we are trying our best, but it's very kind of an early stage.
Yeah, we are early in that cycle, but yeah, it's a good time to kind of transition to XR. Let's talk about it, right? So we have seen that's the thing for a while now, and we see there has been really good use cases in visualization, training, collaboration. So have you kind of tried any of that which kind of worked well, and particularly to make your digital twins much more intuitive, actionable, right? Alex, can you start on that?
Sure. So when you say XR in reference to reality capture or digital twins, like XR means AR, VR, MR. And back in the day, we used to have to start our presentations and explain the difference between all three of them to everybody. I think we're past that point. And then digital twins and reality capture, kind of like almost like a redheaded stepchild of the XR family, but it fuels the experiences. It enables you to design an experience leveraging the data collected from the actual space. So for instance, building an AR scene, I will take a point cloud from an area of our shop floor, and then I'm kind of good to go. I could design the AR experience on a computer and know where my image markers that would evoke the AR experience are going to be placed in that twin. So there's a great partnership between digital twins and XR. There's other bespoke creative solutions also, and one that I'm compelled to mention is something that I'm calling digital signage, where I'm able to build like an XR experience by way of somebody having a phone or tablet, scanning a QR code, and then it will open the digital twin from their perspective in the area that they're standing in that building with specific information to meet their task, depending on the individual that scanned the QR code. So there's a lot of XR capabilities that can be derived using digital twin data as a baseline.
Awesome. Carrie?
So I'm trying to go the exact opposite. I want to stop people from using QR codes. So the way that we're doing it is you have your tablet, you point your tablet at the equipment, it says you are here, you get a little menu option. What do you want to do? Do you want to look at a document on it? Do you want to run a procedure? Do you want to see work orders against it? And kind of my overall hope and dreams, like we were in Minority Report, where I could pull up the drawing and have it here, and I can have my model here, and I can have my process information here, see how everything's working. But right now, we're stuck in tablet world, but we're also using it for navigation in the plant. So I point, it says you are here. I'm like, I'm the new kid. I don't know where I'm going. I'm trying to get to this piece of equipment. So using the AR to point me where I need to go, help me get there, tell me how far away I am, whether or not I'm there. Also using it for running procedures. So if I'm supposed to open a valve, close a valve, I don't know where that valve is, using my tablet to help me locate the valve, pointing an arrow at it going, this one. So that's, I'm trying to get no paper, no scanning of individual links or anything like that.
So, you know, I'm also trying to get there, just to be clear. In the meantime, I'm using QR codes.
Yeah.
You know, I saw
As are we.
I saw a compelling demo just about 20 minutes ago from a vendor in the expo hall that has something pretty cool where you can take data from a standard reality capture that will then localize you in the world space. So there's a lot of these solutions. It's my North Star, and
Yeah.
we're going to get there.
Oh, yeah. Absolutely.
Michael.
Yeah, so, you know, across this space, we've got a couple different things that we've worked on. We do use it quite a bit for inspection. So we've cut down a lot of, you know, I'll call it velocity and efficiency of the person when they were having to do inspections. It was kind of a direct improvement there. And then also during inspections, we found, we did an audit at one point in time, and we realized that the people that were doing these inspections were missing multiple steps in the inspection. And so it was not only improving the quality of the inspection, it was helping them perform the inspection even faster. And so those were kind of two wins where we used the XR capability for inspection. Yep. And we're using it in other areas too, but that's just a simple case. Yep.
Awesome. Yeah, for us uniquely, like we have, like I think we all talk about how it augments, you know, humans to do things better. For us, one of the, you know, pleasant experience or refreshing experience has been that we can actually augment how the robots do stuff, right? In terms of the automation, right? Just providing the spatial mapping, understanding of the spaces, and being able to provide that information to the robots go a long way in terms of improving that automation effort. The other thing that we have noted is, like, you know, we talk about active task guidance, and many times we feel resistance from people who have been working for 10 years. Don't tell me what to do step by step, right? Like, I know it. It's okay. Then we take a step back and say, okay, do what you do. Can you put on a headset at the end just to watch your back and just maybe for 5 minutes do a scan and tell you if by chance you missed anything, so that the inspector doesn't have to come and tell you, right? So some of the things that kind of worked for us, and obviously all this thing, as you go and do, you learn, so you go from there.
Yeah, you know, I want to say that remote inspection and floor walks can be executed by a compliance officer, and they can be able to validate if everything's up to snuff, so to say. That's been a big win for us at Blue, actually. We have a EHS department, Environmental Health and Safety, and they make sure that like a bucket of paint isn't left open, or much other things incredibly more critical than that, but just to give you an idea of things that they can inspect remotely.
That brings us to some lessons learned that we can share with the larger audience. Jolly, why don't you start with some lessons learned?
So for us, the first lesson learned was when you have a lot of legacy equipment and you've paid so much for it, and you discover that those machines they're as good as you just having a manual machine, or you talking to the suppliers of those equipment and you say, hey, I want to do this, I want to do that, and they tell you that this is not possible, that is not possible. At the end of the day, you discover that you might not be able to connect and you might not be able to build a digital twin solution. So for us, we kind of learned that early enough. And then when we start shopping for new machines, the first question we want to ask the suppliers is, hey, can your machine do this and that? And if they said no, then we look at the other guys who have similar equipment. So for us, the lesson learned is how to connect legacy equipment and how to get information from those legacy equipment. So I believe a lot of industry are also dealing with the same, because some of this equipment are built to last for 20 years because they cost a lot of money. And then you're talking about a solution that is going to drive improvement, and it's going to be dynamic when it comes to new technology. So that's one of the lessons learned. And I think also the other most important lesson learned is we have a lot of engineers. Like in my team, we have about 40 engineers just in my sections. And some of them, really, they are not used to this kind of solution. So you don't want to be the only source of truth, right? Because means if you're on vacation, means if you're somewhere, you are doing something important, they have to call you and ask you, how does this work? So you want to kind of train and help your team to have the capability and the experience to help also use this solution to drive improvement. Because if you work directly with customer, that's internal customer right now, maybe the production supervisor, maybe the production manager or the production director, they're going to be asking questions that you don't want to be the only source of truth, because it's easy for people to believe when all of you speak the same language. If you're the only guy saying, hey, this is what this is going to be doing, and because there's a lot of challenge to have to justify or to build a use case for some of these solutions as of this time, right? Because either you call it digital twin, you call it XR or anything, especially when you work in the manufacturing environment, there's a lot of challenge to build a use case, especially when you run a finance department that tells you that everything you have to implement has to bring payback. Right? So there's a lot of use case. So you don't want to be the only one that have the knowledge. So you want to be able to kind of also carry everybody along so that you all can speak the same language.
Awesome. Alex, you want to go?
Yeah, I think one of the biggest lessons learned is that after you perform a scan, a reality capture, you can move a table and all of a sudden that scan is stale, that data is now out of date. I think the direction that we need to move is, instead of a human or a drone perhaps, or even a robot, which we've experimented with, the direction that we need to move is static arrays of sensors constantly performing the capture and making that information available. I think that's a huge win. I also think the ability to import models into the twin to experiment with floor plan layouts and advanced visualization techniques of that nature are also critical. I think measurements have been a big win. Just to be able to remotely jump into a space and perform a measurement, it might not seem like a big deal, but it's a huge win, and it's some of the most traffic to our sites are for people to perform remote measurements. So I wouldn't have expected that, but that has been a huge win at Blue.
Awesome. Yeah, so one thing that I think maybe there are 6 minutes. Okay, let's talk about what's holding us back. Like Mamta, like what's holding you back in terms of
what's holding you back? That's a very good question, and I think that technology is not a challenge, right? It's the people and process is the challenge. Okay. We invested a few years in this technology, and of course we have been able to put one type of digital twin, fully scalable, enterprise level, but still I think we need to engage both the top management as well as our end user, right? Top management so that we can continue this one, and the end users so that they are the real user who are going to adopt this technology, right? So that's a little bit challenge for us, and I think, and as I said, right, for us the challenge is we need to expand our digital twin ecosystem beyond 3D models. So of course reality capture, even though we have some kind of it, but this is not enough to, show the return of investment to the management. So,
Carrie.
So we are kind of in a little bit of a recycle of our digital twin, because like starting over from the beginning, and yesterday, I can't recall her name, but the lady from Walmart, she said something and I was like, that's what our problem is. Everybody sees a software to have a single purpose. They are looking, it's Excel. We use Excel for everything as engineers. So they think that there's only one use case for the digital twin. And I'm like, no, I'm not going to pigeonhole you into what you can do with it. And so we're in that, okay, there's people, process, technology, and our hump on the people change. We're like, here's what it is. It's curated information for you. It's contextualized. Use it however you want to use it. And they're like, okay, you haven't given me a specific reason, and I prefer to just call Bob, because Bob knows everything, so I'm not going to go play in this. I'm just going to go talk to Bob. So change management of people is really the barrier for us right now.
Okay. We have 4 minutes or odd. Why don't we spend 1 minute each? Let's talk about how can this audience can help. Alex, start with you.
Yeah, sure. Okay. I mentioned the need for dragging and dropping models into spaces. I also talked about leveraging reality capture data to build AR experiences. It would be great if there was one unified platform that plugged into all of our CAD data and then converted those respective models into the format that we can import into our space, and then had a toolkit that lets you design AR experiences inside of that model that then worked in the real world. So, hey, if any vendors are out there that want to custom tailor something for us or build the solution for the general.
Outside,
yeah.
Carrie?
There you go.
I need HoloLens replacement, because I am so sad. Safety glass rated. Give me something. I can look at it. I get my menus. That's a big hole. Fill it, please.
Also capture on the headset too. That should be a scanner built into your head-mounted display. Why not?
Mamta.
I was looking for the interoperability of these kind of a data, because generally the digital twin data starts from your engineering side of it, but I want that thing to be compatible and think more beyond engineering and operation side, how it can be used in the operation side. So that's what I'm looking for, and of course, I can see many of us has been made quite a strive in this area of the reality capture, so definitely leveraging their knowledge.
Yes, somehow the interoperability becomes it's a two-side of the coin. Like some steps need to be taken from an organizational angle, some from the standards, and then people meet there, right? So, Michael?
Yeah, one area I was kind of a problem, I was looking, a few years back, we did a study trying to find what the right software mix would be to deal with the problem of, we have scenarios where you have the vehicle chassis, you have a supplier who's supplying the transmission, for example, and then we would provide some power pack of some type to it, whether it's the engine or whatever it may be. And we always want to look and understand, basic things like designing it for service and the first integration task and designing it for assembly. But we struggle to use the one-to-one scale capability when it's outside of our walls of Cummins. And so really it's how do we enable that when we're dealing with folks that are not in our walls, and it's secure end-to-end. So cloud for the most part's okay, but sometimes it falls apart when we look at where's that data cached at? Is it cached in the headset? Is it secured if someone takes it and reverses engineer it and stuff? So we're kind of on a bit of a mission right now to reevaluate. So I've talked to a lot of people in the expo to understand kind of where things are at. But we need, that's an area we need help. And it's got to also be globally capable in being able to deal with latency, because we have global teams. And so,
Jolly, what's your highest priority?
So for us, across my factory, everybody has to put a safety glass on. Once you go through the factory, you have those glasses on your face. I'm looking for a solution that can tie everything, especially when it comes to the work instruction, because those employees who has been there for many years, they don't want to look at your work instruction because they feel the noise. So I'm looking at a solution that will help me get there. I don't need HoloLens because I think it's too big. I need something that's kind of just exactly like your safety glasses, and then you can see everything. And so that's kind of what I'm looking for.
Awesome. So yeah, we'll wrap up. What I realized that overall, as much as the adoption is a technology problem, it's also an organizational problem. And as we go from all the data, AI, and visualization, I think it's all like in an iterative process. I don't think so we're going to be going there anytime straight. It's a path that we have to take, and I think there's a lot of collaboration that has to happen across the board. So yeah, let's make it happen. Let's keep the dialogue going. Yeah. All right. Thank you very much.
Thank you.
Check out GridRaster's booth.
Yeah.
Thank you.
All right. Thank you.